Okay, this is video 6 for the semester review, and we'll cover 61 through 70. The ages of the population of a town are normally distributed with a mean 43 and standard deviation of 14. So we have a mean of 43, standard deviation of 14. The town has a population of 5,000. How many would you expect to be aged from 22 to 57? Well, first off, let's draw a chart and see what we have. All right, so we're sitting here with a mean of 43 and a lower bound of 22 and an upper bound of 57. So we're going to go ahead and find out how much is there. So this is going to be a normal CDF because we're working with a normal curve. Our lower is going to be 22. Our upper will be 57, lower, upper, mean of 43, standard deviation 14. Mean, standard deviation. All right, so here we go. Second vars, norm, CDF, lower 22. By the way, I'm getting this straight off of this chart or this graph. Upper part of the shaded is 57, mean of 43, and the standard deviation they told us was 14. But all we calculated right here is the probability. So we have this is our probability, so 77% out of 5,000. So what I'm going to need to do is go, you know what? Expected value equals N times P. So in this case, 5,000 times that probability of 0.7745. So I'm just going to take this value right here and times it by 5,000. And I'm going to take the answer that's closest. And I get 3872. The answer that's closest is letter C. So please remember, this is kind of a difficult problem. We had to find the probability first, which was 0.7745, and then we multiplied it by 5,000 to find out how many. So, which of the following is the best estimate for the standard deviation of the distribution shown in the figure? So this looks like a normal distribution. And remember, 99.7% of the data, 99.7% of the data is plus or minus 3. Well, that means how many places do I have? 1, 2, 3, 1, 2, 1, 2, 3. So the difference between them is all happens to be 10. So because it looks like I have a difference of 10 all the way down and all the way up, my standard deviation is 10. Please remember, there's essentially going to be plus or minus 3 standard deviations, which means plus 3 and minus 3 gives me 6 standard deviation. So 1, 2, 3, 4, 5, 6. All right, a machine produces electric components. 99.7% of the components have links between 1.176 and 1.1224. Assume the data is normally distributed. What are the mean and the standard deviation? So let's start off with the mean first. All right. So real quickly, once again, they tell us 99.7%. So that means that's plus or minus 3. So we're almost all the way out here. So this is going to be, in that area is 0.997 is there. And they tell us the lower part is 1.11, or 1. I wrote that wrong, excuse me. The lower part is going to be 1.176. The upper part is 1.224. Well, the mean is just the average. And since this is right between them, I can add those two and then divide by 2 and get my mean. So 1.176 plus 1.224. All right. So we added those two up, and then we divide by 2, and we end up getting 1.2. All right. Well, that gets rid of this one. That gets rid of this one, but it leaves C and D as possibilities. So at that point, I need to figure out how am I going to find the standard deviation? Well, up above, we talked about the fact that if it's 99.7, that's plus or minus 3. So I need to have 6 standard deviations between them. So let's take 1.224 and subtract the lowest, 1.176. So from the lowest to the highest, it's spread out 0.048. But we have to divide that by 6 for the plus or minus 3. And we end up getting 0.016. Now, how did I mess that up? So let me pause this for a second and see what I did wrong. Okay, I said I was going to divide it by 6, and apparently I didn't. So I'm going to clear the screen, and I'm going to go 1.224 minus 1.176. And I need to divide it by 6, actually divide it by 6. And when I divide it by 6, I get 0.008. And so I get letter D is my answer. All right. The Fresha Tea Company packs tea bags marked as 250 grams. A large number of packs of tea were weighed, and the mean and standard deviation were calculated at 225 and 2.5. So we have a mean of 225 and a standard deviation equal to 2.5. Assuming the data is normally distributed, what percentages are underweight? Okay, so let's draw a picture. They told us it was normal, so I'm drawing a normal curve. They tell me the mean is 255. They're advertising them or they're marking them as 250. Well, 250 happens to be below 255. Now we want underweight, which means we want less than, and you have to remember the normal distribution goes to negative infinity. So this is going to be a norm CDF because we're working with a normal distribution. Our lower bound is negative infinity, which we use the negative 9994. We're going to shade all the way up to 255. That's our upper. Our mean, I said that wrong. This should have been a 250. Our mean is 255. And our standard deviation is 2.5. So here we go. Second vars, normal, CDF, so negative 99999. And make sure you use the little negative at the bottom of the calculator. Do not use this for normal, use this one to make it negative. Our upper bound was 250. Our mean was 255. And our standard deviation was 2.5. And that tells me, it says 2.27. Well, we're going to have to choose the one that's closest, and the one that's closest is 2.5%. Okay. I know we have 2.2, which is not exactly that, but that is our closest one. All right, so that's number 64. Moving on to problem number 65. Gina's doctor told her that the standardized score, her Z-score for systolic blood pressure as compared to blood pressure of other women her age is 1.5. Now, this is a positive Z-score. All right, so if I'm drawing a normal curve, Z-scores are centered at 0. So positive 1, or this is positive 1.5, is above it. Okay, so this is going to be above the mean. So question is, what does it mean? Well, Gina's systolic blood pressure is 150. It doesn't mean that. It just means that her z-score, she's 1.5 standard deviations above the mean. All right. And Gina's systolic blood pressure is 1.5 standard deviations above the average, in other words, the mean for women her age. Okay. Because that z-score is the number of standard deviations. So her blood pressure is 1.5 standard deviations above. It's not 1.5 above, it's 1.5 standard deviations above. All right? Because a z-score is a number of standard deviations. Number 66, students pass a test if they score 50% or more. The marks of a large number of students were sampled and the mean and standard deviation were calculated at 42% and 8%. So mean is 42, standard deviation is 8. Assuming the data is normally distributed, what percent of the students pass the test? So I'm going to make these decimals like they should have been. So this is 0.42, and this is going to be 0.08, and this 50% is 0.50. All right, so they're distributed normally. And my mean is 0.42. So that's the average. But they had to make 0.50 in order to pass. Okay? So anything above that is a passing score. So this is a norm CDF. The lower is 0.5 because that's the lowest part of the shading. This goes all the way to positive infinity, which is the positive 99999. The mean is 0.42, and the standard deviation is 0.08. So here we go. Second VARS, norm CDF, lower is 0.5, upper, mean of 0.42, standard deviation 0.08, and we end up getting 0.1586, and our closest answer is letter B. For the normal curve, what percentage of the scores fall between 70 and 80? Well, that's kind of nice. So here's the thing, though. They did not give us directly the standard deviation. So we know the mean right here looks like it's at 70, but we need to figure out the standard deviation. Well, 1, 2, 3 standard deviations above, 1, 2, 3 standard deviations below. How much are they changing by? Well, they're changing by 5. So that means our standard deviation is 5. So in this particular case, we have a norm CDF, the lower, because they went between 70 and 80. The lower in this case is 70. The upper is 80. Our mean happens to be 70. And our standard deviation is 5. So if we go do the norm CDF, lower 70, upper 80, mean 70, standard deviation 5. And we end up getting 0.477. So about 47.7% are letter B. For the normal curve above, what percentage would fall between -5 and 7? Well, once again, we need to figure, they didn't tell us directly our mean, but we can figure that out from the picture. So our mean in this case is 4. Our standard deviation, well, let's make sure that we have 6 spaces. So we should have 1, 2, 3 below, 1, 2, 3 above. How much are these changing by? Looks like they're all changing by 3. So our standard deviation is 3. Okay, and they went between -5 and +7. So this is the area of interest. So this would be a norm CDF. In this case, our lower happens to be -5. Our upper, by the picture, happens to be 7. Our mean is 4. And our standard deviation is 3. So second var is norm CDF, lower -5, upper 7, mean 4, standard deviation is 3. Note that please note I got all that information from this drawing. All right. When I calculate it, I end up getting about 84%. All right, about 84%. So 84% would be my best answer. And on this particular set of questions, 84% is letter C. Moving on to 69. For the normal curve above, what percent of values fall between 30 and 58? Fall between 30 and 58. So that's what we're looking for, but since we're working with the normal, we know we have to have the mean and we have to have the standard deviation. So the mean equals, oh, well, that's pretty easy. The mean is right in the center at 44. We need the standard deviation. So we need 3 values above, which we have 1, 2, 3, 1, 2, 3 below. And so what is it, the difference in between? Well, the difference in between each one happens to be 7. So our standard deviation is 7. And we're looking for the area between 30 and 58. So this is a norm CDF, since it's a normal curve. Lower part of the shading is at 30. The upper part of the shading is at 58. The mean is at 44. And the standard deviation is at 7. Second vars, norm CDF, lower at 30. Oops, let me put that up on so we can see it. Lower at 30, upper at 58, mean of 44, standard deviation is 7. And 0.9544, so about 0.95 is our closest. All right, so letter D is our answer. And because of the way the problems worked out, I'm going to stop this one right here before we start the next video. So we're going to stop at problem number 69.